Hi everyone, welcome to my channel Edu-spectra. So now let us move on to our first exercise on our polynomial chapter, exercise number 2.1. The first question is, which of the following expressions are polynomial in one variable and which are not? State reason for your answer. Okay, so let's see. Here our first question is 4x square minus 3x plus 7. Okay, so they are asking you whether it is a polynomial in one variable. Okay, so here we can see that this is a polynomial in one variable because here we are having one variable and this is definitely a polynomial. Why is it a polynomial? Because the degree present over here or the power of the exponent is a whole number. So definitely this will be a polynomial. Okay. So now let us move on to a second one, which is y square plus root 2. So we know y square plus root 2. This is again a polynomial in one variable. Also we can see the exponent or the power of the variable is a whole number. Okay, we know 2 is a whole number. So this also definitely is a polynomial. Okay. So now our next one is 3 root t plus t root 2. Okay, if you see this one, okay, this is a polynomial in one variable, but can we call this thing as a polynomial? No. Why? Because we have learned that a given algebraic expression will be called a polynomial if and only if the power of the variable is a whole number. If you see over here, this root t, I have told you, this root t, we know how can we write this root t as, we can write it as t raised to 1 by 2 plus t root 2. Okay, so if you can see over here, the power of the variable, it is not a whole number, it is a rational number. So definitely this cannot be a polynomial. Why? Because the power of the variable is not a whole number. So this is not a polynomial in one variable. Okay. Now our next one, y plus 2 by y. Here also this is not a polynomial in one variable. Why? Because if you see over here, y plus, if I am bringing this y to the numerator, I will be getting it as 2y raised to minus 1. Okay. Here also if you see, the power of the variable is a negative number, which is an integer. It is not a whole number. If and only if the power of the variable is a whole number, we can call it a polynomial itself. Okay. So definitely this also is not a polynomial in one variable. Okay. And next one is x raised to 10 plus y cube plus t raised to 50. Okay. If you see, all the powers of the variables are a whole number. But now in a question they have asked you which of the following are polynomials in one variable. But if you see in this question, here we are having three different variables which are used, that is x, y and t. So this is not a polynomial in one variable, it is a polynomial in three variables. Okay, but a question was identify the ones in one variable. So this also is not a polynomial in one variable. Okay, so which are the polynomials in one variable? Your first one and the second one are polynomials in one variable. Rest all are the other, this 3 and this 4 are they are not at all polynomials, and your fifth one is polynomial in three variable. It is not polynomial in one variable. Okay, I hope it is clear to you. Okay, so our next question is, write the coefficients of x square in each of the following. Okay, we have to write the coefficients of x square. So we know coefficient means the constant term which is present along with the variables. Okay, so if you see the first one, here we are having a x square. So what is the coefficient of x square? Coefficient or the constant term. So if you can see over here, the coefficient present is 1, because we know 1 into x square is x square itself. So the constant term or the coefficient of x square present over here is 1. Okay. Now the second one is 2 minus x square plus x cube. Now here we are having our x square. Now what is the coefficient of x square present over here? Yes, it is minus 1. Why? Because we know here we are having minus x square. So it means when we do minus 1 into x square, we will be getting minus x square. Minus 1 into x square, we know it is minus x square. So the coefficient of minus x square is minus 1. Okay. Now the third one is pi by 2 x square. So here we are having our x square term. What is the coefficient of x square, or the constant which is present along with x square? It is pi by 2. Okay. So pi by 2 is the coefficient of x square. Now the next one is root 2x minus 1. Okay. Now if you see this algebraic expression, here we can see that there is no x square term, isn't it? There is no x square term. Here there is only an x term present. So here, since there is no x square term at all, okay, we cannot determine the coefficient of that term. So definitely the coefficient of x square will be 0. Okay, I hope it is clear to you. Okay, so now our third question is, give one example each of a binomial of degree 35 and a monomial of degree 100. Okay, so first of all, let's see. We have to write a binomial with the degree 35. So we know, what do you mean by a binomial? Binomial means a algebraic expression with two terms. So whatever algebraic expression you are writing, so you should be having two terms. Okay, so here we are having two terms, here also I have written two terms, here also I have written two terms. And also the condition is that the degree should be 35. That means the highest degree of the variable should be 35. Okay, so here I have written few examples: 2x raised to 35 minus 6, x raised to 35 minus 1, minus x the whole raised to 35 plus 2. All these are binomials. Why are they binomials? Because each of them are having two terms only, and also the power of, or the degree of each of them is 35. Okay, so you can write your own examples also. Okay, for this. Now the second one was to write a monomial of degree 100. So we know that monomial means it is an algebraic expression containing only one term. Okay, so here in all the examples I wrote, we are having only one term of x or the y. Okay, for example, x raised to 100, 2y raised to 100, minus 4x raised to 100, root 2x raised to 100. All these are having one terms and the degree. Degree means the highest power of the variable, which is 100. Okay, so these are a few examples for monomial with degree 100. You can also write your own examples for the exam. Okay, I hope it is clear. Okay, so our fourth question is, write the degree of each of the following polynomials. Okay, so here you are being given few polynomials and you have been asked to find the degree. So we know, what do you mean by degree? Degree means the highest power of the variable term. So if you see 5x cube plus 4x square plus 7x. Okay, so here which is the highest power which is present over here? It is definitely 3. Okay, so the degree of this polynomial is 3. Okay, similarly, next one, 4 minus y square. So if you see, which is the highest power present over here? It is 2. Okay, similarly, the next one, 5t minus root 7. So if you see, the variable term present is t, and what is the power of this t? It is 1. Okay, so we know t raised to 1 means t itself. So the degree of this polynomial is 1. Okay, and the last one, 3. We know 3 is a constant polynomial, and we can write 3 as 3x raised to 0. Because we know any number raised to 0 is 1. Okay, so 3 into 1 is 3 itself. So here the degree of the polynomial will be what? 0. Okay, I hope it is clear to you. So whenever you are being asked to find the degree of the polynomial, always look at the highest power of the variable. Okay, So now let us move on to the fifth question. The question is, classify the following as linear, quadratic and cubic. So we know that a linear polynomial is a polynomial which has degree 1, quadratic is a polynomial having degree 2, and cubic polynomial is a polynomial having degree 3. Okay, so let's see our first one, x square plus x. So if you see, the degree of this polynomial is what? 2. Okay, you should look the highest power. So our first one, that is x square plus x, is a quadratic polynomial. Okay, the next one is x minus x cube. Okay, here which is the highest power of the variable? It is 3. Okay, so we know a polynomial with degree 3 is called as a cubic polynomial. Okay, our next one is y plus y square plus 4. So here the highest degree or the highest power of the expression is 2. So we know that a polynomial with degree 2 is a quadratic polynomial. Okay, next one is 1 plus x. So here if you see, the highest power of the variable, so this x we can write it as x raised to 1. So the highest power here is 1. So we know a polynomial with degree 1 is called as a linear polynomial. Okay, next one also 3t. Here also the highest power, we can write this t as t raised to 1. That means the degree of the polynomial is 1. So this also will be a linear polynomial. Okay, then our next one is r square. So here also if you see r, the power of the variable is what? 2. So we know a polynomial with degree 2 is a quadratic polynomial. Okay, then our last one, seventh one is 7x cube. Okay, here also if you see, the power of the variable, the highest power of the variable or the degree of the polynomial is 3. So we know a polynomial with degree 3 is called as a cubic polynomial. Okay, I hope it is clear. Okay, so by looking at the degree we can identify whether the given polynomial is linear, quadratic or cubic. Okay, so I hope you have understood all the things we have discussed in our class today. So now we will meet in our next class with a new topic. Thank you. Please like, share and subscribe the channel.